okay, is we're going to be talking about data comparison. So it's important to understand how you can compare data, or populations as they say it. So go ahead and title your paper Comparing Populations. And to make accurate comparisons, in order to be able to make accurate comparisons, you need to utilize a couple of our different forms of measures that we learned yesterday. So when we're talking about averages, okay, so we tend to say who has a higher average or who has a worse average, right? Who has a higher or lower average, or on average. Who performed better on average? Who performed lower on average? Who read more on average? So in terms of averages, who remembers one of the measures of center that we could use as an average? Paris? Mean, right? We could use mean. Now, who also remembers mean is only usable in what situation? Armando? When there's no outlier, okay? So it's the one that you want to use when there is no outlier. That's important. There's an outlier present, mean might not be the best representation of your data set. Who can raise their hand and tell me the other form of measure that we were able to use to compare averages? Trang? The median. Okay, so the median was another form, and that is best used when there is an outlier. Okay, it gives us more of a centralized point of the data set, regardless of having an outlier. Okay, and median's perfectly fine too if you've got no outlier. I mean, you know, it's not going to throw it off, but typically speaking, if it's talking about no outlier present, mean is our best form. Median is good for when there is an outlier present. So if we're talking about comparison on average, who's performing better, these are the two values that we're talking about. Okay, now consistency. Yesterday I used that word, or variability. So if we're talking about consistency, okay, we're talking about who is more consistent. I think I spelled that wrong. I think it's spelled with an E. Yeah, it is spelled with an E. My apologies, guys. I thought that looked wrong. All right. So consistency, who is more consistent? If we're talking about it being more consistent, what does that mean about the data, about the individual pieces of data? Bridget? Less variability. That means your data values are probably more compact, right? They don't have as much of a gap between them. So going from like, oh, if I have a data set that is, I don't know, 3, 7, 8, 10, 14, okay? This is pretty consistent because if we're looking at the gap that's between them, to get from 3 to 7, there's a gap of 4. To get from 7 to 8, there's a gap of 1. To get from 8 to 10, there's a gap of 2. To get from 10 to 14, there's a gap of 4. It's not really large jumps to get from one number to the next. So who is more consistent? That also means that they probably have a smaller what? Like, so remember we talked about two values that can talk about variation or variability. Who remembers what two values those were? Centers of variability. Alex, what's one of them? The IQR, right? The interquartile range. So we're talking about interquartile range. And what's another one that we're talking about? Divya? Range. So interquartile range and range. Interquartile range and range are fair representations for consistency. Now, if it is more consistent, here's the important thing. The more consistent, the lower the interquartile range and range are. You're looking for small interquartile ranges and ranges itself. If your range and interquartile range are large, then they're not as consistent. So for example, let's take a look at another one. If we're saying something like, here we've got 3, and then we've got, 14, and then 21, say 30, and maybe 39. Okay? Not too bad. We still don't have anything that would really be considered an outlier. And the reason that I say that is because when you're looking at it, the gaps are still similar, right? To get from 3 to 14, that's a gap of 11. To get from 14 to 21, that's a gap of 7. To get from 21 to 30, that's a gap of 9. To get from 30 to 39, that's a gap of 9. So they're not that far apart in terms of gaps, but in relation to their range, the range of the first set is going to be 11 versus the range of the second set is going to be 36. You have a much bigger range. So it's not as closely compact. It's more spread out. So it's not as consistent. Okay? So these would have a larger range or interquartile range and therefore are less consistent. So we'll write this down here. These are less consistent. Less consistent is going to have a higher IQR and range. So it's important to understand those terminologies so that when we're doing a comparison between two data sets, two populations, the way that we compare them is we first focus on, well, who performed better on average and who is more consistent, meaning that we're going to be able to use their data to make a reliable prediction. Okay? So with that being said, those of you who do have a cell phone with you today, I'm allowing you to take it out for a moment. And you're going to look at your screen time average. Does everybody know how to find their screen time average?
No, I don't have a phone actually.
You don't own a phone? I saw your phone earlier today. If you don't know how to find your screen time average, you're going to go to your settings. Go to your settings. You'll go to where it says screen time, and then it will relay to you your daily average.
What would be considered healthy screen time average?
Well, I mean, you guys also have to realize you guys live on your phones. I take care of a small child at home, don't I? I have 2 small children. Do you think I have time to be on my phone all day? No. All right. So you're going to identify how much your screen time is. If you don't have a phone with you today, but you think you have a realistic idea of how much time you spend on your phone, then you're welcome to provide that information to us. If you don't have a realistic idea, if you really have no clue how much time you spend on your phone on average for the day, then you don't have to provide that, okay? What I'm going to have you do is when you are ready with that information, you're going to stand up because I don't want to call your name out and it be on the video. In fact, actually, we're going to pause the video for a moment, and when we come back onto the video, it'll have all the information displayed. And what we're going to do, because again, it's comparing populations, so I can't just gather the information as a class. I have to split you up into two types of groups. What two types of groups do you think is a really easy way to split you? Alex? Well, if I'm trying to collect how much time people spend on phones, Veronica, I'm never going to be able to stop doing that now that she's done that. Veronica. But again, it doesn't compare the average amount of time people spend on phones. I'm trying to compare two different subgroups. Come on, guys, look around you. There's a very easy way to split you guys up into two subgroups. Bridget, please help me, honey. Bridget? Thank you! Girls versus boys, okay? It's the common split. All right. When we come back to the video, we'll have the data. All right. So we've got our information for our girls. We've got our information for our boys. And what we're going to go ahead and do is we're going to plot this. We're going to plot it in a box and whisker plot. So that way we can get an idea of the different spreads, how it looks. And then we're going to go ahead and we're going to identify mean from the data set. We're going to identify the median from the data set. We're going to identify the consistency. So we want to know on average which group tends to be on their phone more. And then based off of each group, which group has more of a consistency in its value, meaning that there's not too big of a spread between the values. Okay, let's go ahead and go to our next little piece of paper. If you have room on yours, awesome. I do not have room on mine. You can write on the back if you're comfortable with it. I can't write on the back because mine is in pen, so it bleeds through. So the first thing I want to do is I'm going to go ahead and talk about the girls. We're going to first, before we ever do any kind of data collection, or data comparison, we first need to take the data set and put it in order from least to greatest. Why is it important to have it in order from least to greatest again, Veronica? It's easier to find that median, right? It's not about easier, that's how you find the median. You have to have it in order from least to greatest to be able to identify your median. Now, we've got 15 numbers in our data set. So does that mean we're going to have one center or two centers? One. Remember, odd number of data will have a direct center. Even number of data will have two values in the center that you have to then do what? How do you find the dead center if you've got two centers? You add them together, divide it by 2. And welcome back, babe. All right, so let's go ahead and put these in order from least to greatest. So who can tell me which value up here is my smallest value? Divya? 3. And we have a whole lot of them, right? We've got 1, 2, 3, 4 3s. So I'm going to go ahead and write 4 3s. I'm going to go 1, 2, 3, 4. Okay, after that, what's the next number, guys? 6, right? Is it 5? Oh, there's a 5. That's why we cross things off. We have a 5 here. So let's go ahead and cross off the 5. Put that down. Next number that we've got is a bunch of 6s. And let's see how many we've got. We've got 1, 2, 3, 4, 5 of them. So we're going to put 1, 2, 3, 4, 5. Okay? And then what's next? 7. How many do we have? 2 of them. 1, 2. So we'll cross those off. Okay, and then looks like we've got a 9. After that, looks like it's the 12 and then the 14. Okay, and always, once I've put them in order, because I know I originally had 15, I'm going to count through here, make sure I still have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've got them all in order from least to greatest. Okay, so I'm going to go ahead and cover up that information for the time being, and we're going to go ahead and start calculating some stuff on it. So I'm going to go ahead and calculate my mean or my median. Okay, doesn't matter which one again. Now, when is the only time it matters? When there's an outlier. Is there an outlier? No, because the numbers are all pretty similar. There's not too big of a gap going between them, right? We've got a gap of 2, a gap of 1, you know, a bunch of gaps of zeros, and a gap of 1, a gap of 2, a gap of 3, and a gap of 2. It doesn't have anything that stands way out from the rest of the data. All right, so we can calculate mean or median. Let's go ahead and just do both. So let's go ahead and start with the mean. We're going to calculate the mean. All right, so that means that we're going to add all of those numbers together and then divide it by 15. We're going to add all the numbers together and divide it by 15. Go ahead and do that right now, just the same as I'm going to do it. All right, if you've added them all together, raise your hand. All right, Paris, what'd you get? When you added it all together? You got 96? Anybody else get something different? What'd you get? 97. All right, let's go ahead and do it together by hand. We've got 4 3s, right? That's 12. We've got a 5. We've got 5 6s, so that's 30. We've got 2 7s, that's a 14. We've got a 9. We've got a 12, and we've got a 14. Okay, so 96, right? I'm just making sure that everybody got the same amount. All right, 96. 96 over 15, so we're now going to do 96 divided by 15, and that gives us 6.4. So on average, for our mean, it's saying 6.4. Let's talk about our median. Now, our median is the number that is smack dab in the center. So if you just use your fingers and hide the numbers as you go, you know, hide here, hide the next ones, hide this one, hide this one, hide this one, up, up, up. It all comes down to a 6. Are they close to each other, right? 6.4 versus 6. Those are pretty consistent with each other. So on average, around 6 or 6.4 for the girls. All right, let's talk about our consistency. We want to know how consistent is the information going to be. So we're going to go ahead and first identify the range. Remember, the range is to go ahead and take the highest number, our maximum, which is 14, and we're going to subtract our lowest number, which was our minimum, our 3. And that's going to give us a range of 12. I'm sorry, 11. I wrote 11 and I said 12. 11. All right, now our interquartile range. The way that the interquartile range works is, again, you have to know what your median is, right? So again, 1, 2, 3, 4, 5, 6, 7. So here is the 6 that represents our median. That's the 6 that represents the median. Our interquartile range needs the median of the lower half and a median of the upper half. So that means based off of these numbers that are to the left of the median, we're going to find the median there. That's going to represent our first quartile. So here we've got 1, 2, 3, 4, 5, 6, 7 numbers. So what is our median for these first 7 numbers? Yo-chan? 3. This 3 right here is going to be called our first quartile. What about for our upper half of our data? The upper half of our data, what's going to be the median there? Maya Isabel? 7, right? And it's going to be this specific 7. That's our third quartile or our upper quartile. So then when we're doing our interquartile range, we're finding the difference between those two values. So we're going to take 7 and subtract 3, and that's going to come out to 4. Take 7, subtract 3, it comes out to 4. Okay? So now we're going to go ahead and plot this. It's always important to look at what it looks like as a box and whisker plot. So we're going to draw a little number line. Now the nice thing is since I know what my highest and lowest numbers are, I don't really have to go any further than that. So I'm going to go ahead and just start all the way back here and say I'm going to start at 3 and I'm going to end at 14. And now I want to try to make sure that I'm consistently spacing them so that I get an accurate look at what the box and whisker plot's going to be. Halfway between 3 and 14. What's the halfway point between 3 and 14? Well, 6 is only 3 away from here, and it's 8 away from 14, okay? So we're trying to find roughly what the halfway point is going to be. So if you subtract 14 and 3, you're going to get 11. What's half of 11? 5.5, right? So if we were to go to 8.5, that would be roughly where the halfway mark is. We're not going to write 8.5. What I'm going to do is I'm just going to go a little bit lower than that and put an 8. A little bit higher than that, and I'm going to go ahead and put a 9. And then try and evenly space. So we've got about 10, 11. Oop, I didn't do a very good job of evenly spacing. Ooh, who used my whiteout? And we're going to just try, get a rough estimate between them. Okay. Again, we're drawing it by hand. It's not going to be perfect, but we're just doing the best we can. That's why it's better if you guys do yours with pencil. Okay. All right, so now we're going to go ahead and plot our extremes. We've got the lowest value being our 3, the highest value being our 14. We've got our median is over here at 6. We've got our first quartile is also at 3. So notice that my lowest and my first quartile are the same. And then my upper quartile is here at 7. And now we're going to go ahead and place our boxes. We don't have a whisker that can connect my lowest to my first quartile, so literally my lowest and my first quartile are going to be on the back end of the box. And that's what it looks like. Just giving you an idea. Now, knowing that this right here represents 25% of your data, 25% of your data is just 3s. (25% of your data falls between 3 and 6. 25% of your data is 6s and 7s. And 25% of your data falls between 7 and 14. Right? All right, let's go ahead and focus on the guys now. Anybody still need to copy this? Go once, twice. So here we go. All right, let's take a look at the guys information. So I'm going to go ahead and display the guys. Zoom out a little bit so that we can go ahead and write things down in order. All right, boys. Lowest value. What's our lowest value up here? 1. How many ones do we got? We got 2 of them. So we're going to go ahead and write 1, 1. All right, what's the next one? A 2. We've got a single value of 2. Okay, then what? 3s. How many 3s we got? Just 2 of them? All right, 1, 2. All right, next one is a 4. Next ones are 5s. We've got a 1, 2, 3. You know, we'll go ahead and get rid of that, my husband's data. Let's just leave it to the kids in the class. We don't want to skew it off too far. We want to make it more realistic to what is in this classroom. All right, then we've got a bunch of 6s, right? 1, 2. Well, I know, but it's more than 1. I could say a bunch. All right, and then the last one is our 7. All right, and so we have this based off of 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, let's go ahead and populate. Let's identify the mean. Okay, so we're going to add them all together, and we're going to divide this by 12. Adding it all together and dividing it by 12. 2, 4. Huh? Yeah, all of them add together. 48. Okay? Yes? Right? 2, 3, 4, 7, 8, 10, right? 14. 14. Yeah, okay, yeah. 48. All right, divide. 48 divided by 12. 4. So on average, for their mean, is about 4. Let's tighten their median. Now they've got 2 centers. Bless me. They have 2 centers. So let's find the 2 numbers that are in the centers. 1, 2, 4, 5, 6. Okay, it's a 4 and a 5. These are our 2 centers. So that means that we've got to find the center that's right in between them, don't we? What's in between them? 4.5. And when in doubt, you just add them together, right? 4 plus the 5, that comes out to 9. 9 divided by 2, that comes out to 4.5. And because of the fact that there is no outlier, they are pretty close to each other. There is no outlier, so that means the mean and the median are relatively close. Okay, now notice that because I didn't have a value to actually circle as my dead center, I just went ahead and drew a line here because I'm going to need that when I am finding my interquartiles. Okay, let's go ahead and talk about range. The range, what's our highest number? Lowest. When we find the range, it's 6. Okay, smaller range. Smaller average. All right, interquartile range. That's when we have to start finding the first and third. So looking at my first data set, the first half of my data set, what is the first quartile value going to be? We don't have a dead center, do we? We have 1, 2, 3, right? Right in between here, it's going to be 2.5. What about for my upper? 5.5, right here in the center, 5.5. So we're going to do 5.5 minus 2.5, that's going to come out to 3. All right, and then if we go ahead and plot it, I'm going to try and go ahead and use the same number line setup that I have here, only so that we can see how it looks in relation to what our first one was. Okay, I'm starting it at, oh yeah, I have to write the 1. Oh, that means I'm going to have to go further behind. Okay, I wanted to get it to be consistent there. So we're going to have to put the 1s over here, because that's where it would have been on this one. Okay. All right, so we have a 1 and a 2. That way we can have it kind of relatively set up to way we've got it here. 5, 6, 7, 8, 9. There we go. Try and get them almost lined up to the way that the first one was. So that way we can see what it looks like in relation to each other. All right, plotting our smallest number. Our smallest number is a 1. Our largest number is a 7. Plotting our first and third quartiles. Our first quartile is 2.5. Our third quartile is 5.5. Okay, putting a box around those quartiles, and then we have our median. Our median is at 4.5. And now look how they compare. Gosh, Veronica, you and your 14 hours just threw it all off. So now comparing, on average, what gender tended to not be on it as much? The boys. Okay. Who tends to be more consistent? The boys. Okay. They had lower range and interquartile ranges than the girls. They had a lower average than the girls. Okay, so you're making inferences, and people utilize this sometimes. And you know what? Sometimes people will use this kind of information, and then they might look at test scores and see if they can make a correlation. Is there a relationship that exists between kids being on their phones more versus grades in school? So they're looking at that stuff, and yeah, there's going to be people who are going to be not the norm. Right? There are going to be people who are never on the phone and might not do very well. There's going to be people who are always on the phone and still do very well. To get a more realistic view of this, should I only be checking this group? No. Because, again, why are you in this class? Because you scored well. You do well. You perform well. So if I wanted a more realistic view on making comparisons about average amount of time spent on the phones, I got to get to a lot of different groups and a lot of different age groups too. Maybe 8th graders are on their phones more because maybe parents decide, hey, 8th grade, I'm going to go ahead and buy them a phone, and then they just go crazy. Okay, so that leads back in the whole sense of talking about biased versus unbiased. What kind of sampling method did I just do here? Who knows? Paris? Convenience. It's easy. You're very easily accessible to me because you're right here. Okay? Now, what if I asked you guys that, hey, as you're leaving, if you want to, go ahead and just write it down and put it on my desk. What would that be? Voluntary response, right? If I went ahead and say, okay, guys, as you're leaving, I'm going to ask you a question, and I ask every third person that leaves my room. What kind of method is that? Again, systematic. And then if I just put everybody's information into a jar and then I just pull it out. Random samples. Okay, good. Yay, I'm glad you guys have an understanding of that. Now, you're going to be seeing problems where you're looking at data information in tables. It could be displayed like as an actual data set. It could be a box and whisker plot that you would be comparing. It could be a dot plot. Do you guys know what a dot plot is again? Right? It's got the number line and then it's got the dots above it to say, hey, we've got, I have one person who's at a 12, so I'd have one dot above it. But I don't have anybody at an 11, so I wouldn't have anything there. And, oh, I've got a whole bunch of 3s. I'd have 4 dots above the 3. That's the dot plot. So you might be comparing those dot plots to each other. Okay? Also, as a reminder, if we're talking about symmetry, just recurring back to what we were talking about yesterday. If a data set is symmetric, so I'm going to write one more thing down here. Let's say that we have the following. We've got a 1, a 2, a 3, 4, 5, 6. All right, so I have this dot plot here. This is going to be an X, and we got 1, 2, 3, 4, and then actually we'll even put a like that. So 1, 2, 3, and then there. All right, based off of what I have here, what is my median? Real quickly, what's the median? A 3, right? The median right here is the 3. It's smack dab in the center. Is this a symmetric data set? Yes. It follows from the left side of our median. It's a mirror image to the right side of the median. They are mirror images. So when they are mirror images, without having to calculate, what's the mean? It's the same. 3. Remember, if symmetric, mean and median are the same. Calculate it. Do that right now. I want you to calculate what the mean is. Add 1 plus 2 plus 2 plus 2 plus 3 plus 4 plus 4 plus 4 plus 5. And then divide that by, what is it? 6, 7, 9. Divide it by 9. Yeah, when you add it all together, you're going to get 27. 27 divided by 9 is going to give you the 3. So symmetry makes your mean and median equal. If it's not symmetric, they're different. Go ahead and open up your computers. You are going to have a quizzes on comparing populations.